Welcome to InfoBytes. In today's video, we are going to discuss about Little's law. Let's see the definition of Little's law. Little's law is a theorem that determines the average number of items in a stationary queuing system based on the average waiting time of an item within a system and the average number of items arriving at the system per unit time. It says that this theorem is used to determine the average number of items in any queuing system based on two parameters that are waiting time of an item within the system and the average number of items arriving at the system per unit time. We can calculate the average number of items in the system or that particular queue. Now, let us take a small overview of origin of Little's law. MIT professor John Little developed Little's law in 1954. The initial publication of the law did not contain any proof of the theorem. However, in 1961, Little published proof of that. There is no such situation when the described relationship does not hold. Little later received recognition for his work in operation and research. Now, what is the mathematical representation of Little's law? So mathematically, it is written as L is equal to lambda into W. What this letter represent? L is nothing but the average number of items in a queuing system, whereas lambda is the average number of items arriving at the system per unit time, and W represent the average waiting time spent by an item in that queuing system. Now let us see a numerical based on Little's law. So let us consider John having a small coffee shop. He wants to know the average number of customers queuing in his coffee shop to decide whether he need to add more space to accommodate more clients. Currently, his queuing area can accommodate no more than 8 customers. So for that, John measured that on average 40 customers arrive at his coffee shop every hour. He also determined that on an average, a customer spends around 6 minutes in a store, or that is 0.1 hour. Given the inputs, John can find the average number of the customer queuing in his coffee shop by applying the Little's law. So let us see first what are the given in question. We can see two numeric, that is 40 and 0.1. So lambda is nothing but 40. Here if we read this statement, what it says that 40 customer arrive at coffee shop every hour, that is 40 item arriving per unit time, that is nothing but lambda. As we discussed the definition of Little's law, and in the mathematical representation as well, we saw what lambda is and what W is. Again, W is the waiting time of an item in the queuing system. So here the time is given in 6 minutes, and we converted it into hour because the lambda is given, and that is 40, and it is based on hour. That is why we converted this 6 minutes, that is time spent by an item, into hour. So so that we can multiply the same unit value. Now simply we'll use the formula, that is L is equal to lambda into W. We'll keep the value of lambda and W and multiply. We'll get the answer 4 customer. That is 4 customer is the average number of the customer arriving at the or of that particular queuing system. Now let us look at the applications of Little's law, where it is applicable and it is used. So basically it is used in manufacturing companies to predict lead time based on the production rate and the amount of work in progress. Similarly, software performance tester use lattice law to ensure that the observed performance results are not due to bottleneck imposed by the testing apparatus. Other applications may include staffing emergency departments in hospital, and just before this we saw an example of retail shop, so it can be used there as well. Thank you for watching the video. If you like the video, please like, share and subscribe. Thank you very much.